All right. Well, hello, everybody. Welcome to a very special episode of WordCast. It is special for two reasons. One is more epic than the other. The first reason is that this is the 69th episode of WordCast.
We're one away from 70.
Immediately makes it extremely important because that means we are 31 away from 100, and that's a valuable number. Mm-hmm. So the 69th episode, I think you guys will enjoy this. We dressed up very special for this.
Because I never wear long sleeve shirts.
And I never wear this exact shirt on the podcast. Then the other reason that this is, the most epic reason that this is an important one is because we have a lot of news regarding AMD EPYC, including 64 cores. Mm-hmm. So we'll get to that in heavy detail, of course. This episode, I want to warn anybody that's watching it, is going to be fairly heavily AMD focused. And anybody that's watching the cutout, because this will be a cutout, it's a little lengthy, but we go into some pretty great detail of the announcement.
Yeah, normally I would say, if you watch the cutout, watch the rest of the episode.
Yes, but in this case, the cutout's gonna be like 30 minutes probably. Yeah. So and if anybody that's not wanting to watch something that long, I still encourage you to. We'll go over the more important, less detailed aspects first, so you can leave earlier if you want to. But realistically, I think a lot of this is extremely important and should be.
Because a lot of this ultimately is going to be data center focused. It all carries over to what we're going to see with the consumer hardware.
And not just that, it also is helping paint a picture of competition between AMD and Intel that's going to help the consumer market in ways other than just innovational compute power, but just pricing and platform stability and all kinds of other stuff like that. So this is really cool.
It was a weird week where it was pretty slow on news. But, there's some stuff so we're recording this on Tuesday the 6th, which is election day.
It's important to note that, yeah.
Yeah, so there's not going to be a lot of news up before that because it's election day. That's what the news is covering.
Nobody's talking about anything today other than AMD.
Like AMD covered data center stuff because the people that care about that will care about that whether or not it's election day.
Exactly. It's like, whereas more consumer-based people are more likely to care about the elections more. Yes. But anybody that's watching data center, it's like that's what matters,
And then on top of that, we do have announcements like Samsung is supposed to be talking about their foldable Galaxy phone tomorrow.
Well, we don't know if it's a foldable phone. We just know that it's the Galaxy F.
No, they've said foldable.
I'm kidding.
Okay.
But Galaxy F.
So they're talking about the foldable Galaxy phone tomorrow. And so we'll talk about that next week.
Yes, we'll have a lot on that next week.
Yeah.
We're kind of almost glad that it's not happening today because this is already going to be a lengthy set of news from one company. So,
let's just jump into it.
Yeah. So I guess jumping straight into the AMD news. So AMD had their Next Horizon event, and it was all about data center. So I want to first note that while some of this can apply to consumer stuff coming out in the future, it was a data center focused event. This is a follow up to their 2016 data center event, New Horizon, Next Horizon. I actually like the consecutive naming scheme. I think that's kind of clever. So a lot of big news. They did mention things about the consumer and gaming market in it in terms of they want to push computing in that, but they didn't actually have any news. It was just data center news. And I did see one thing that was interesting is AMD had a little kick at Intel, which Intel's done. I just like it when companies come up with clever ways to hint at fighting each other. AMD said up on stage, they said AMD's approach is different to the competition. What other competition is there other than Intel? Not looking at incremental changes, which I appreciated. Yeah. So that was something that was just fun. Poking fun at the competition is always good. So it's been 15 months since EPYC 1 came out, and it's been doing well considering. It scales really well. And there's a lot of advantages to it versus the Intel parts in terms of core count, in terms of PCIe lanes, in terms of value, especially very heavy emphasis on that one. And that's been really, really good for AMD. And they have been slowly pulling back market share in the server space and the data center space. But of course, we all wanted more, and I think the data center wanted more, and it takes time to switch to. And so they've continued to push things. And what I want to talk about before we actually get more heavily into EPYC specifically, everything surrounding the Zen 2 architecture and die.
Yeah.
Because that's what is going to apply to all the other stuff that's coming out at like CES and Computex next year. And so for those of you that don't want to watch this whole thing, stick around for this part, because this part will definitely apply to you in the future. And I'd say probably the next part too about some Radeon stuff. So 7 nanometers confirmed. Now, by confirmed, we already knew that was the plan. Was Zen 2, they already said, but this is actually a thing. We know for sure that it is 7 nanometer. It's a modular design, as we've expected before. And they are actually shipping samples right now. It's sampling. Zen 3 is already in development and on track, and Zen 2 is going to be going to market in 2019. So for the data center, and also assuming other stuff.
And Zen 4 is also in development.
And yes, Zen 4 is in development. So
they did say that Zen 3 is essentially like a 7 nanometer plus, like a refinement of it.
Right, which still makes me wonder, since we had Zen and then we had Zen Plus, right? Are we going to get a Zen 2 Plus is a question, because if they're calling that 7 nanometer plus, then is Zen 2 Plus going to be 7 nanometer plus?
Ultimately, by the time this actually releases and is being sold, it's going to be about 18 to 20-ish months, if we're thinking like February to April, probably, if they're going to do a big announcement in January at CES.
Oh, yeah.
And so with that, if every one generation of EPYC, they do 2 generations of consumer hardware.
Yes.
Then that lines up perfectly to what we'd be seeing of, 7 nanometer plus is for...
There's going to be more consumer improvements. And that's actually, the data center changes slow enough that I think it's a smart move to not refresh that too frequently. Intel refreshes it because they want more money. But I think the better thing to do is, an extra 200 or 300 megahertz average clock speed as an example, say across all cores. That's a big deal, but it's not anywhere near as big of a deal for the data center as it is for like gamers and stuff, where that stuff can really push you over the edge and help you compete. So I think it's a good move on their part, is to do the refinements on consumers, which also gives them more time to perfect the other stuff. Rather than trying to do things on a yearly basis. So they had a big focus with this architecture change on Infinity Fabric, and I'll get a little more into detail on that in relation to like Threadripper and EPYC style stuff. But the hope is that we're going to have lower latency on the Infinity Fabric, especially between like CCXs. They communicate via Infinity Fabric. That'll help the more consumer-based stuff. And then multi-die chips is obviously more important for Infinity Fabric. But they had a big focus on that, which is great, because that's been like the only like issue point really with Zen as a whole, has been things that are relying on the Infinity Fabric, not so much between CCXs, but between dies and between sockets, has been a little bit not as good as it could be. When you have things communicating over something that's very latent, that can cause a lot of issues.
Especially something that is not designed for it.
Exactly.
And
whereas
anything that's designed to run on processors is not designed for it.
Other than data center workloads. And data center workloads weren't as sensitive to this, but consumer workloads, and this will still help with data center workloads that are very parallelized for a single task, but consumer workloads like gaming as an example, there are a decent amount of games I have a Threadripper 1950X, and there's a decent amount of games that if I let the Windows scheduler toss the game back and forth between the dies, it'll cause serious issues to make the game nearly unplayable. Call of Duty Black Ops 4 is a good example of that. And I'm hoping that they can do stuff to improve that, because right now I have to manually set process affinity to force it to a single die to make things function good. And so the hope here is that they're able to fix some of that stuff. So they continue talking more about 7 nanometer, how it's a very big improvement. It's they said it's a better choice over 10 nanometer. Of course, that was another shot at Intel, but Intel's 10 nanometer is different from what TSMC's 10 nanometer would be. But the idea is 7 nanometer is a pretty long-term node, so I think we are going to stick with it for probably a good 2 years, maybe a little more, which is fine. We're going to have refinements of the 7 nanometer node, but we won't have a die shrink.
I think it's going to probably be about 3.
It might even be 3. Yeah, I know they're betting on the long term with this. It's TSMC has pushed really hard to make a really good process node here.
Because if it was going to be 2, I don't think they'd be saying Zen 3 is going to be 7 nanometer refined.
Oh, yeah, that's a good point. Yeah, so we're looking at like 3 to 4 years before we see a die shrink to maybe like 5. Yeah. So the die shrinks are really starting to slow down now, guys. I think 7 nanometer and Intel going to their 10 nanometer are like the last 2 really big steps we're going to see in that realm until something really impressive happens. Now, there's enough money being dumped in the area that could happen, but I don't think we're going to get smaller than 3 in the next decade. I really don't.
Yeah.
I definitely think we'll get to 5 in the next decade. I don't even know if we'll hit 3 in the next decade because of how crazy this is.
I could see it happening for extremely custom server parts, but that's about it.
Yeah, and stuff that's maybe lower frequency.
Yeah.
And stuff
I could
that
see
too.
IBM having 3 nanometer manufacturing capability for some of their own products for them.
Yes, for them and for their data center customers.
Yeah,
I could see that. Yeah. So something I wanted to note too here is a lot of AMD's success. Obviously, they have their own engineers and everything, but a lot of their success and other industries being able to compete really well against the likes of, say, Intel and Samsung is thanks to TSMC. And so shout out to them for figuring out how to get 7 nanometer functional.
Yeah.
I'm still not entirely sure if they're using extreme ultraviolet to carve out 7 nanometer or if they have figured out a way to do it with regular photolitho. I know they were on the crux of that. I know Samsung's the one that's investing even more heavily in EUV as far as I understand. But really just thanks to TSMC for making this possible, because if the node wasn't there, it doesn't matter how good the architecture is. Things are still expensive. It's not like they could just charge next to nothing for like a 14 nanometer node to compete with Intel. They really needed this here, and this competes very well. This, from my understanding and everything we know so far about 7 nanometer from TSMC, hard to know for sure because the only products we have out are Apple products. But yeah. But the idea is we think it is beating Intel's 14 nanometer. Of course, it may be just on time, so to speak, where I think we might actually finally see 10 nanometer from Intel next year, I think. Now, 7 nanometer is 2 times the density, as we'd expect. Now, they're claiming it uses half the power and can do 1.25 or 125% performance of the older Zen, I can't even talk right now, Zen Plus stuff. 125% that performance with the same power usage. So that's 25% higher performance, which is a pretty big deal right there. Of course, the density is really big, really big deal there. More on that towards EPYC, but we might actually be, to touch on a little here for the people that are maybe going to leave before we get to the EPYC stuff, the die shrink and the more dense for the same amount of cores is a really big deal, because you consumers might be getting 12 or 16 core chips on AM4 platforms next year.
And what if the base Ryzen hardware was 6 instead of 4?
Yeah, or even 8
instead of 4.
Exactly. That right there is a huge deal. Huge deal. And so I'm hoping that we see something like that for consumers, and that really starts to push hard against Intel, and they need to push the core count up further. We will be talking, I forgot to put this in the doc, but we will be talking about Intel's fun 48 core chip when we talk about EPYC, because Intel did some fun stuff, and it actually looks to be a good chip, but they did some fun stuff. So anyway, though, this is like a really big deal. Now they're claiming in the announcements and everything, they're claiming that 7 nanometer is the top process node of the entire world right now, and is beating Intel's. That was kind of the claim up there. Of course, that's in comparison to Intel's currently shipping 14 nanometer plus, and that could change with Intel 10 nanometer. So I do want to note that, but right now this is the best process node in the world, which is really impressive in terms of what can actually be mass produced and sold. So that's a big deal, and I again, going back to Infinity Fabric and how big of a deal that is, I'm very excited. They're calling it a second gen Infinity Fabric, so it's not just some minor improvements. It must be something fairly major. We don't know a lot about it yet, unfortunately, but they're claiming faster pipeline, and then they're also claiming things in regards to IPC and speculative execution, improved branch prediction, better prefetching, all that kind of stuff that's related to speculative execution, and some spectrum mitigations, hardware-based ones, which we fully expected that to be a thing. Of course, mitigations are mitigations, not solutions. But
now I wonder if, and they haven't talked about it because the research hasn't shown if they're affected, but they probably have been testing themselves. I wonder if they are doing anything behind the scenes for this chip that would affect the potential vulnerability when it comes to simultaneous multi-threading.
The port smash?
Yeah.
It was just talked about? Yeah, so they didn't mention it at all here, but I would assume that some of what they've done here could help with that. I will be honest,
imagine up until the point where it's publicly confirmed that it affects AMD, they'll just work on dealing with it.
And ignore talking about it,
Because if by the time people have tested and know it is an issue on AMD, you have it like fixed or at least mostly
or close
mitigated.
to fixed, and you can talk about it without just promising things.
If it, you know, it's like, oh, this is an issue, and you're like, oh, we already dealt with that.
Yeah, which is like super cool.
Yeah.
So hopefully that's the direction they're going. We assume port smash is AMD is vulnerable to it. We just can make
Pretty
that
much
assumption. It's
anything with hyper-threading should be affected.
Simultaneous multi-threading. Hyper-threading is Intel only.
Okay.
Which is just Intel's name for the same thing.
Yeah.
So even things from IBM that are like quad-threaded, so to speak, that kind of stuff could be affected.
No, do they have 4 times the issues?
I don't think that's how that works, but I'll be honest, I haven't read enough into port smash to really know for sure how big of a deal it is.
Port smash, to me, from what I read, seemed like one of those things that's like, it could be used very, very badly, but it's not easy enough to use that it's of a serious concern.
It's similar to Spectre and Meltdown in that way. More specifically, Spectre. Meltdown was a little bit bigger of an issue, but yeah, like I feel like researchers are at a point right now where they're finding such insane hardware level issues that it's like, okay, these are things that these companies need to fix, but also there's a reason nobody's exploited it in the last 20 years
that we know of.
Okay, that we know of, but exploitation is it's pretty rare. Okay, you don't always know the method, but it's very obvious when you're exploited.
But as more and more data gets stored in the cloud,
it becomes a bigger issue, especially when we're talking about things like access to memory and stuff like that.
When you have like bank records, when you have social security numbers, when you have entire people's like everything about them on the internet when it comes to Facebook and Google.
Yeah.
Yes, it might be insanely difficult, utterly absurd to try and take that hardware or to try and take that data by actually like infiltrating a facility.
But maybe it's worth it.
Yes.
Yeah, and that's that. Yeah. The data's higher value at this point. So to finish up with some of the changes regarding Zen 2 specifically versus EPYC and whatnot. So they have a bigger op cache. They have hardware mitigations for Spectre and Meltdown, we mentioned, or Spectre, Meltdown doesn't affect them, we mentioned that. But they also have memory encryption enhancements, which is really good for the server market, for the virtualization market. And some of that memory encryption enhancements may actually be in relation to port smash. Again, though, I haven't read into port smash heavily enough to really judge that yet, so take that with a grain of salt. And then the I.O. die is 14 nanometer. And they have lower I.O. latency and lower power usage for the same I.O. throughput. That's all a big deal and really cool. And Zen 4 is in development, which we mentioned earlier, but they also talked a little more specifically at the end. But they didn't really give any details of what Zen 4 is going to look like. Yeah. They gave details of Zen 3.
Yeah.
So.
What I will be really excited about from this is if I can get an 8-core with better IPC that clocks a bit higher than my current chip, with less power consumption and less heat output. That would be awesome.
It would be awesome. And I love what AMD has done regarding the less power consumption and less heat output is they've pushed things further rather than being like, oh, more efficient for the same thing. They make things more efficient. They release the same thing, of course, but they also release stuff that's like the next level up.
Yeah.
So we have, chips like Threadripper where it's like they consume just copious amounts of power, like the 32-core Threadripper can pull like 300 watts, right? And that's not overclocked. And seeing power consumption like that is like sounds ridiculous, but what they've been able to do with the efficiency and then push that. And that's something I've complained about heavily about the market as a whole for a long time. I think more specifically Intel versus NVIDIA and AMD not doing a very good job of, we made efficiency improvements, let's not push it any further. Like, what's the point there? I get it for like mobile and stuff.
Yeah, I think that's ultimately where most of the efficiency improvements that Intel was working on was focused.
Was laptops and the like, because that market's grown.
And also what we've seen is that, now what I thought when I saw constant efficiency improvements from Intel is that they were working on figuring out ways to improve efficiency that would just be applicable in general. Because like let's say you were the leader and you knew that eventually someone would come back and challenge you. You have a couple of options. You can either just mess around for a while, which is what a lot of people said Intel was doing. Or you can work on other things that you generally couldn't focus on in competition. If you could instead of focusing on increasing core counts and performance, if you could find ways to improve efficiency that you could use going forward for a long time.
Okay, and that's true.
What I was hoping that Intel was working on when I saw these efficiency gains. Is I was like, okay, I'm hoping that what they're doing is finding out ways to essentially ensure that when they do decide to bump up core counts and speeds and stuff, they can do so much more efficiently than everyone else, because that would be a really smart use of their time and money right now.
Yes.
But would also mean.
But Intel doesn't want to glue dies together,
yeah.
So that's part of where their core count increase trouble has come from, which more on that a little later. But yeah, I agree, and so I think efficiency obviously is it's a great thing,
especially when you have hundreds of computers in a data center.
Exactly, it ends up being a big deal. Yeah. It's just that they didn't push the envelope anywhere else, and they still aren't.
Yeah,
and AMD's been pushing core counts higher and higher and higher.
From what we've seen with Intel's own products, they didn't even figure out efficiency in general. They just made slightly more efficient products.
They did, yeah. And it's like, I feel like Intel almost put too heavy of an emphasis on Moore's Law and trying to improve the process technology rather than going other directions as well. And I feel like core count increase has been long awaited. We were stuck on quad core for so long, and we're not anymore thanks to AMD. And I would say nearly entirely thanks to AMD.
Oh, 100%.
Like completely, yeah. And
I think that
before that we were just stuck on quad cores for consumers.
If not AMD, the thing that would push Intel to have done something would be ARM in like 4 years.
Yeah.
Because we're seeing ARM for laptops compete now.
We are. And I think Intel should have been pushing core counts way sooner than they were. And they kind of have. For monolithic dies, they definitely have been doing that on the server market. But, of course, it's still... They didn't push the consumer market the way I wanted, and as consumers, there was no reason that we should have been stuck with quad cores for 6 years with minor improvements. Yeah. It was dumb.
At the very least, they should have bumped it up to 8 worth of consoles are.
Yeah. It was just a waste of time and resources, and people just dumped money into stuff that didn't make any sense, and it was just lame. And there's a reason that so many people for so long stuck with their 2000 series Ivy Bridge Intel chips. Because why move on?
It seems like Intel spent more of their R&D money figuring out how to charge for different products. For that, and then also just on random stuff.
Yeah, and and it's funny because they could have done a better job and have been more competitive and more profitable now. Now, sure, they're still slaughtering AMD in terms of money, but that is slowly changing, and Intel doesn't like that, of course.
Isn't AMD up to 13% CPU market share is what I saw? 12 or 13?
I think that's correct. I think that's factoring in all-encompassing, whereas the majority of that is consumers because they change quicker, especially enthusiasts and gamers. Gamers more specifically. Streamers, a lot of streamers are starting to use AMD because you get the cores really help.
Yeah. I think after what we've seen with some of the announcements today, we're going to see that number change quick.
I think so. And this is just incredible, the stuff about EPYC that we'll get to a little bit after Radeon Instinct here. But yeah, I just think it's really cool to see AMD pushing this direction, which I feel like Intel, you were having so much trouble with the next process node, you needed to move some of it in a different direction simultaneously. Creative. Exactly, because you can't just the same thing. That's the definition of insanity. They could have been working on other aspects of improving performance rather than just maybe clock speed. They kind of were, and die shrinks. And it's like, come on. So now we'll jump into Radeon Instinct, because some of the stuff that's happening here could trickle down into the consumer market. I think it's a little less likely because this is all Vega stuff, not Navi stuff. We did not see Navi. I'm sorry. Spoiler. Sucks. But Radeon Instinct is AMD's line of compute high-level server data center processors, or GPUs specifically. And of course, this whole event was all about data centers. So it makes sense that they did this. Now, we're looking at 25 teraflops in performance. Their GPUs already with Vega on the compute end have been used with Alibaba, Baidu, and AWS. First 7nm GPU in the industry, though, and that's a big change because NVIDIA is still stuck on 12nm, which is just 14nm. So very impressive that AMD is actually leading the forefront in terms of GPU process node technology, not architecture. I think NVIDIA is still pretty far ahead on that, but hopefully they're catching up. So anyway, they're all cloud-focused GPUs as well, which is something we'd expect. That's a popular term to be used that investors will understand. So I get why they talked about that a lot. But I want to talk more specifically about the Radeon MI60, which is a data center GPU that they showed off and talked about. It is a 7nm based GPU. As far as I understand, it comes out next year. Vega-based architecture. Now, I want to specifically note that Vega is very good in terms of compute. We've talked about this before. It may not be that great for gaming. It may not be that great at high clock speeds, but for servers, it's actually been very good. There's a reason that AWS and Baidu and stuff have been using it, is because Vega's not bad as an architecture. AMD's shown they can do good architecture, but the node and what the architecture was being applied to were the more complex areas and the areas that they didn't do as good of a job on. The 7nm node could help with this. I would love to see 7nm Vega for gaming at a good price, but I have a feeling that that puts a very big stress on TSMC, which is already stressed because you have a lot of gamers that would want those GPUs then if they were good. B, I think Navi's going to be a bigger jump, and Vega already has a bad name, even though it was very competitive. Actually, the Vega 56 specifically has a bad name in terms of availability and stuff like that, and so they probably don't want to use that name for the consumer stuff anyway. So it's the industry's only hardware virtualized GPU. I'm not going to get too much heavily into that because it's cool, but I don't know enough about what they mean here to really talk about it, even though I do virtualization. They didn't really get into enough detail about it to make it matter to me. But 13.2 billion transistors, and it was a 331 millimeter squared die. Now, it sounds like a small die, because we saw, the Titan V was 852 millimeters squared, which is massive, and I think we're at 754 millimeters squared with things like the 2080 Ti, RTX 2080 Ti.
But those have so much that's not GPU.
They have so much that's not GPU, but also this shows 7nm. That's an important aspect here versus 12 and 14. So 331 millimeters squared, 13.2 billion transistors, that's a lot in a given area. That's very impressive. So the 7nm is going to help a lot with that. They're saying 25% higher performance for the same power usage. That's really, really cool. We kind of expected that. That's the same number that they're giving for Zen 2.
It seems like that's the change to 7.
Yeah, that's what it comes down to, and that makes sense. You have double the density, obviously 14.7, and then you have good improvements in terms of power usage and performance with the power usage. Of course, that right there could be a big help with Vega on the gaming market if this trickled down into gaming, because power usage was one of the concerns. Was Vega 56, it beats the 1070 for a lower price, but you run into high heat output and you run into high power consumption, the former being more important to gamers, but still. Now, 50% power reduction for the same frequency. That was something that was really notable to me too, going back to potentially this going to gaming. Again, I doubt it, but if it does, that right there is a big deal. And even that right there, coming primarily from like 7nm being a big jump, does trickle down to Navi when that does come out to consumers. And that's important because that was one of the biggest areas, as I just mentioned, that Vega was lacking versus Pascal. So that was cool. It has end-to-end ECC memory. Cool. It is the world's fastest floating point 64 and floating point 32 PCIe based GPU. Now, I don't know why they specifically stated PCIe based. I don't know if that was saying... So, NVIDIA's new stuff uses NVLink. So the NVIDIA could still be winning on that front then. They're just not PCIe based. And I don't know... I know some of the really massive server things that NVIDIA is specifically shipping for compute GPU-wise is all NVLink. There's no PCI from my understanding. But I wonder if they're also factoring in, it has an NVLink bridge, so it's not just PCIe, so we can say this. I don't know. So that was one where I was like, okay, but we do know Vega is good at compute. So 32 gigs of HBM2. That's kind of expected, but cool. I think that's just so amazing. 32 gigs of RAM on a GPU.
Yeah, it is.
Now, here's where we get into the stuff that's a bigger deal for gamers and also bigger deal for what applies to EPYC a little later and Zen 2. These GPUs are PCIe 4.0 based. Yes, AMD is the first to market with 7nm PCIe 4.0 GPUs. That money they're making on the CPU market's being pushed towards something. This is really exciting. I'm pretty mind blown by this. Of course, NVIDIA's got NVLink, but PCIe is not proprietary by any means. And NVLink well, I don't think technically proprietary. It's proprietary.
Yeah. And I mean, ultimately, what we're seeing is that for consumers, NVLink is going to just be for GPU to GPU communication.
Right, whereas
This
PCI
is GPU to everything.
Everything to everything.
Yeah.
In the end, yeah. And so it's a big deal. PCIe 4.0 by 16 slot is going to give you 64 gigabytes, not bits, per second bidirectional.
That's all?
It's a lot of data. That's a lot of data being moved around. So that's very impressive. And they also have developed Infinity Fabric for GPUs. GPU to GPU communication via Infinity Fabric.
That I'm not surprised
about. Now, I'm not surprised, but that's a big deal. Now, that's more like the NVLink direction of stuff, right? Mm-hmm. And, of course, Infinity Fabric is proprietary in a sense.
Are we going to see an Infinity Bridge?
Now, that would be actually a great name. I don't know if that's going to happen because on the consumer end, especially if they come out with Navi and it's PCIe 4.0 based, on the consumer end, they're probably just going to do the communication between them on the PCIe bus because that's what they've done before, and that can work quite well if you have the available bandwidth. But for the data center, this is a huge deal. Now, it would be very interesting, though, to see like some kind of Infinity Bridge for Navi or something. Would be really cool.
Because if Infinity Fabric 2 is especially a significant step up in latency...
Yes, that would help with GPUs a whole lot.
Yeah, if we could have GPU to GPU communication at a much, much lower latency, I think that would be the thing that would make Crossfire, in this case, much, much closer to that end goal of perfect scaling. Yes,
it would help with that a lot.
Yeah.
So I wanted to look up some stats for you guys before jumping into the next part of this Infinity Fabric stuff. They are rating Infinity Fabric between GPUs at, per link, 100 gigabytes per second.
That's all?
That's all. Nothing at all. Nothing at all. Very, very crappy. Now, those of you wondering, NVLink. What's NVLink's bandwidth? They have a rate of 35.3 gigabytes per second. Mm-hmm. Now, they're different. They function differently, and we don't know enough about this new version of Infinity Fabric to judge whether or not it's that drastic of a difference, right? Because it depends on how many links per bridge, so to speak, or something of the sort. So that gets into more complex territory, so I'm not going to make a judgment there, but that is a lot of data. Although, compared to PCIe 4.0, it's not even that massive anymore.
Yeah.
So,
and see, that's the thing is, 100 gigabytes per second link between GPUs if they did something like an Infinity Bridge, and if it, at that distance, could keep that bandwidth,
then that's
that's going to be a better setup than GPU to GPU over the motherboard.
It would be, yes, lower latency, and that's why NVLink's a thing, and why high bandwidth SLI bridges are a thing on 1080 Ti setups and stuff like that. Now, I want to mention they specifically state no bridges or switches, but that doesn't necessarily mean for consumers. So that's why we are still talking about bridges and switches. Whereas all of that, they didn't really talk about whether or not that's through the board.
Yeah.
I would assume that's what they mean by that, unless it's like through the board to the CPU and back or something weird like that.
Yeah. Because when it comes to consumer stuff, ultimately, so for data centers, you design applications around the hardware.
Yes.
Especially when custom stuff.
Do. Yes.
Whereas with games, they're generally, made to support a bunch of stuff. So the less common something is, the less support it's going to get.
Exactly.
Crossfire, SLI, not very common, don't get a lot of support.
Yes, whereas stuff like this...
If you can find a way to get, those GPUs to essentially run much closer to if it was one large GPU, then that means less work from the developer to achieve that performance.
Yes. Now, of course, the way this could potentially trickle down to consumer is still iffy, because right now the common way to do SLI is SLI is technically still a proper term for Crossfire as well. But to do multi-GPU config is to do alternate frame rendering. And the issue that you face there is not every frame is created equal. And so that's why you have an introduction of bad frame timing, is you have, this frame took 6 milliseconds, and this frame took 18 milliseconds, and this one took 5 milliseconds. And so you have this issue of lining those frames up where they're coming out at different times.
Yeah.
Because the GPUs are switching back and
Sometimes
forth.
by the time one GPU is done one frame, another GPU is done two.
Two, exactly. And so then you run into sync issues and other stuff like that. And of course, that could make things look really weird if you get an earlier frame and a later frame, an earlier frame after a later frame, right? And so weird stuff like that can happen too. So it's a very complex thing, but of course, ideally, there are better ways to do rendering for multi-GPU. DirectX 12 implements some of them, the lower level APIs.
So latency would obviously be an issue with this, mostly just for the game itself. But what if somebody designed a system that used 3 PCI cards, 2 for the GPUs, and then 1 to process and handle display output, so everything was being funneled into one that could handle organizing the frames? Rather than trying to have the individual GPU. I know you'd still run into the issue of sometimes one's going to be faster than the other. Yeah. But then if you can have...
They would always be lined up is what you're getting at.
So for non-latency specific things, like non-competitive games, this would be a waste of money to develop for just this. But that could be something that would add a small, but potentially, if done right, only slightly more than the frame timing latency, but something that could better sort the frames.
So,
and take...
I don't know exactly how they get the frames to deliver right now.
Yeah.
Because when I was talking about the frames being out of order, that's not really something that does happen. They've made sure they're in order.
Yeah.
But in terms of them being outputted consistently, things like VSync can help with that sort of thing, but of course you get input lag from that, and so maybe there could be a solution there using a third GPU or something weird like that.
Even just a custom, it would still be a GPU, but ultimately a single PCI slot.
Just something really basic that is just a display output that helps.
It essentially would be the bridge, it would connect a GPU to this thing, and then process the info from both GPUs and send it out.
And so this thing's just handling a ton of bandwidth and what frame to send.
Yes.
I don't know. I'm sure... I don't know enough about GPU architecture to say for sure.
Why not? We should patent this.
Okay, you know what? I study into this stuff on as much free time as I have, so... Shh.
You sleep?
I don't sleep. So, anyway, it's interesting. It's exciting. Something I'd love to see, though, speaking of multi-GPU and an extra GPU, third GPU or something, I'd like somebody to be able to figure out how to offload a lot of the CPU-bound AI-type things to GPU, as they can have a dedicated GPU to handle that stuff, so then we don't stop having the CPU-bound issue.
I was still hoping that we would see tensor cores be used for more from NVIDIA, for example, than DLSS. I was hoping we'd see tensor cores for AI processing of game, in games.
Yeah, I think that would be...
I think that, again, going back to, with ray tracing, it's not really going to be a thing until it's on consoles.
Yeah.
I think that that's one of those things that, until it's on consoles, you couldn't justify making a game that had the AI that would require tensor cores.
Okay, true.
Until you can justify saying, we have to set a minimum requirement of this, which would require, for one, both major GPU manufacturers to be able to run it.
Yes.
And then would also require that access to all of those systems, I feel.
And that's actually another point to get at regarding competition, is if this Vega 7nm comes to consumer, or Navi, if either or come to consumer and are actually really competitive with the RTX series with Turing, right? Then we run into the issue of developers have even less incentive to work towards ray tracing specific to RTX, because at that point then you have instead of 20% of the market not able to use it, and let's be brutally honest, the lower performance people that'll care less about it, 20%, versus a 40-60 or 50-50 split of people actually using high-end parts from AMD. That right there is going to make ray tracing even less important, unless developers just won't care, and it'll end up just like Hairworks, where it's
again, I do think that until it's on consoles, which means
it's
until
not
AMD
matter.
does it,
it's
not going to matter. Now, I wonder though. I doubt it. We probably would have heard something by now. No, we would have heard something by now for sure. and maybe we'll wait to see this until next gen, maybe NVIDIA tries to get into the console market.
So AMD's already talked about the console market some, and the understanding that we have is that they've already secured this upcoming next gen.
Yeah. I'm saying maybe for the time after that.
Maybe
maybe NVIDIA's like, okay, we want ray tracing. We know that
that's
literally
possible.
NVIDIA developers have said it's essentially a gimmick until it's on console.
They have, yeah.
And so what if NVIDIA's like, let's go for the console market now. We've finished the thing that we've been working on for a decade. They've said they were working on Turing, ray tracing for a decade
they did,
plus now.
Yeah.
And we know that they chose not to get into the consoles with the PlayStation 4 and Xbox One generation, to focus on their graphics hardware, probably Turing.
Yeah.
Well, now that that's ready, what if then now they decide, okay, now it's time to make a play for the console
ready
market?
is a strong word. I think they have a lot more work to do to make it
I agree.
viable
But
money-wise.
by the time that this would be...
So maybe you're right, although, of course, the next-gen consoles, consoles, we're probably looking at 8 years.
Yeah.
That's
mostly cloud-focused. But
So, that's a good point there, though, is... NVIDIA's worked really hard to get game streaming a thing in the cloud,
and they know that that's
and they know that that's the eventual
forward,
direction. Yeah. So that could be.
And then
we could see a market where consoles are held more by NVIDIA and AMD is more of the PC stuff, very flop from how it is now. Long-term predictions are fun, but we also are limited on time. So time to get into some news of epic proportions.
Oh my gosh, you're going to make these puns all night, aren't you?
I'm going to make these puns eternally because we all know AMD set it up for puns specifically. That was the exclusive reason they called this epic, is because they knew just how epic it would be.
I don't disagree, because if it wasn't for the puns, I feel like this would be a bad name. Because it's like, hey boss, I think we need to buy these epic CPUs. They're epic. Like, they must be really good. Yeah, I mean, they're also called epic. What?
Yeah. I'd be like, what's that mean? Oh, it's spelled with a Y, so it's dope.
Or it's like you just see the list of parts that they want to order, and you see
EPYC. Capital EPYC, and either you assume that's an acronym, or you go, what the?
What are you buying?
What is this thing?
Yeah, you would legitimately question if they're like.
You would, yeah, like
legitimately.
What is this? Yeah, like, or is this like hiding something? So, but the puns, the puns are epic. It's so, and
use your instincts, Ethan.
Use my instincts to determine just how epic this is. So I think though here, I think that this
think of more puns.
is an epic deal.
Stop.
And they got an epic deal with Amazon.
I'm gonna send you to Rome.
Okay, so anyway, enough with the epic puns.
I'm really gonna send you to Rome, dude.
I hate you. More on Rome in a moment. Anyway, I am going to go restart my epic camera. All right, now that I'm done roaming around and that the camera has been restarted. Man, apparently I'm better at puns. I'm a good person. So now we'll jump into the epic news.
I'm not biased.
Anyway, to emphasize that, we really do try to be as unbiased as possible here. But of course, it's been a very big week a very epic week for AMD. And actually, I would say it's been a pretty epic week for Intel too.
Stop.
Okay, I'm so sorry. It's just, they're so easy.
Yes,
easy.
you can say the word epic in every sentence.
Yes, it's so easy. I love it. So
it's
we will
stupid.
actually talk about some Intel stuff that is in relation to the EPYC chips being a little more or less punny here in a little while after we talk about EPYC, which was the biggest announcement here, even bigger than Radeon Instinct. I'd say maybe even bigger than Zen 2 because we got to wait and see for more info on how big of a change that is, although it seems pretty significant. So they first went up on stage and, of course, talked about their past stuff, like EPYC's been partnered with a bunch of major system integrators and OEMs. They've been partnered with Azure, Microsoft Azure, Baidu, Tencent, Oracle, a whole bunch of other cloud providers, cloud stuff, as I put it. But what I put in here is AMD got a very epic partnership Sorry, that's the final one. That was an epic ding. So, anyway, I'm sorry, I can't help myself. Alright, done with that. I promise. Anyway, AMD really did get a huge deal. This was a huge, massive thing when I saw this. This was almost the most important thing they talked about regarding EPYC, was that they have a partnership with AWS now.
Yeah.
So they announced a whole bunch of partnerships there. They had AWS as its own slide, and then waited to talk about the other stuff because of how big of a deal that is. Amazon Web Services is enormous, and just you can't win better than that. Yeah, basically.
So if anyone remembers a while back, a whole bunch of websites, including Netflix, everything went down for a while. That was because there was an AWS issue.
Yes.
AWS is a significant portion of the internet.
And not just a significant portion of the internet, but a significant portion of our government. A significant portion of engineering and research. There are Formula One teams that use AWS to do their wind tunnel testing. Yeah. They rent the server space rather than buying their own frickin' supercomputers. And that's the kind of stuff that's just incredible that they're capable of doing it. And honestly, now people are able to do it on a much more epic scale thanks to this AWS deal. I'm so sorry. Was that too far, guys?
I agree.
So anyway, this is great though. I'm actually really excited about this. Congrats to AMD. That's going to help them pull a good amount of server market back, I think. It's really cool. So AWS, big deal, really awesome. EPYC will be powering 3 new instances of EC2 from AWS, which is Amazon's Elastic Compute Cloud. Which, from what I understand, the idea behind that Elastic it's the one that dynamically adjusts. So your server load goes pew like Fortnite's, which uses AWS. They just go, here you go, more server power. So they have it's funny thinking that they have that big of a reserve of server availability. Just incredible. And then also the R5A and T3A, which are coming in a few weeks. Those instances of EC2. EC2 is a separate instance. Those are separate things, not as big of a deal as Elastic Compute Cloud, from my understanding. And some of this stuff's already available too. The EPYC platform can already be used on AWS in some instances. So 10% lower compute cost for AWS customers that are using it. That's a big deal, because we're not talking 10% out of $5,000 or $10,000.
Yeah.
We're talking companies that dump millions of dollars into using AWS for wind tunnel testing and fluid dynamics and stuff like that, or even higher scale stuff.
Yeah.
That's a big savings. And honestly, if the options between the pricing is that much lower, if I haven't used AWS enough to know, but I'm assuming you can select your hardware sort of to a
especially with this. The way that they were advertising this, it
looks like you can pick to use the EPYC chips instead. And why wouldn't you?
Yeah.
Why wouldn't you? Unless you for some reason need single threaded performance.
Yeah, because they even said the performance stays the same. Users would not notice a performance difference.
The idea was 10% lower cost for the perf, from my understanding, which that's huge. Yeah. That's what?
Yeah.
That's so much money.
If you can save $100,000 off your $1 million contract.
It's how happy's your boss going to be, you know? So, very cool. So, they also mentioned that the larger, some of the really large M5 databases will work on M5A, which can also be EPYC powered. So those are separate things. I don't understand AWS enough to know a ton about things like R5A, T3A, M5, M5A, that kind of stuff. But congrats to AMD for getting such a huge deal here. Now more onto EPYC specifically. So this is EPYC Rome. Rome is the series name. They are saying that it's the first 7nm stuff in the data center. Okay, we kind of expected that. Yeah. 33% better memory bandwidth, which is a huge deal. Memory bandwidth has been a little bit of a restriction for Zen as a whole, even going down as far as all the way to Ryzen stuff, and then Ryzen Threadripper too. There was some memory bandwidth issues and also memory compatibility on the higher end. Now, I don't think that was as big of an issue with EPYC, but I have 3200 megahertz of memory in my computer, and I have 64 gigs at 3200 megahertz. It ran at 3200 megahertz XMP profile just fine. I added another 64 gigs, and now I can't get it to run at the 3200 megahertz. It just continuously, the board can't just train the memory. And that kind of stuff, they've been working really hard to solve, because that's been something that Intel has a ton of maturity on. And I would say their memory compatibility is probably still quite a bit better than AMD's, even on this Zen 2 stuff. Even for consumers, sure, you might be able to run 4000 megahertz or something like that, but the extreme overclockers, you've got to use Intel with their amazing integrated memory controllers. So, now VMware is working closely with AMD, which they specifically wanted to talk about. They didn't give a ton of details, but it makes a lot of sense when you have super high core counts, which, speaking of, Rome has up to 64 cores on a single socket. Now, very important here is that is still the 4096 pin socket. It is still the SP4 socket. Server Platform 4, I'm assuming is what that stood for, right? That's a big deal. And so they somehow have made it, they said it's socket compatible, not just like the same amount of pins. So they have made this massive amount of cores somehow compatible with the same memory traces, the same PCI configuration, and stuff like that for that socket. And that's really impressive, and I don't entirely know how they did that. Now, this is using PCI Express 4.0 as well, which is a huge deal. First CPU with PCIe 4.0. That's massive, which means we might see PCIe 4.0 on the consumer end, because if it's built into the die, why not? Now, speaking of built into the die, though, there's a little bit of weirdness, and I'll put this up on screen so you guys can see this. There's a little bit of weirdness regarding the way the die configuration is. So there's 8 dies on the Threadripper platform. You can clearly see these 8 little dies. They're in like sets of 2 next to each other. But what's weird is in the center, there's this huge square section that looks almost like a giant die. And I don't know what that is, because if you go back to the older Threadripper stuff, and I'll put that up now, it was just 4 dies. So, and if I'm somehow wrong about that, I looked into that today. If that didn't make sense and I'm wrong, then I apologize. But
you'll see the picture.
You'll see the pictures and know what I mean. And so it's at least different, but I don't believe there's any die, any kind of center die or anything like that on regular EPYC, right? And it's just weird. I don't know what that is. I don't know if they're using that for Infinity Fabric and for socket compatibility. Maybe that's what allows this to be. And I don't know I know a decent amount about CPU architecture, but I don't know if they maybe like all the pins connect to that, and that's what's distributing it between the 8 dies, which could help mitigate some issues. And also, if it's working like that, they could maybe have, rather than this memory is connected to this die, this memory is connected to this thing, and whatever die this application's on gets directed to the hub, so to speak, and then to that die. And that would be a really amazing thing, but I still don't fully know what that is. My best guess is that that's to keep it socket compatible, so that you still have the 8 channels of memory and the 128 PCIe lanes, even though there is way more dies. Which also tells us that in the future, if AMD wanted, they could have 16 channel memory and 256 PCIe lanes. Most likely, because I'm assuming they still have the same lane configuration on the Zen 2 dies, but it's such a big difference we don't even know for sure, because it's completely new stuff. So maybe there is less lanes.
It's going to be really interesting to get more details about the technical details of this.
It will, and especially when it trickles down to Threadripper and Ryzen, because that's where things like Infinity Fabric latency, memory latency, die configuration, stuff like that really matters. On the server market, it's not as important because things are so well parallelized or so well not parallelized. Like you have virtual machines running on one core, and so it might not matter as much. So I'm very interested to hear more about that, though. Now, they're saying 2 times the performance per socket. 4 times the floating point performance per socket, though, so that was interesting. But you have double the cores. Of course, it's 2 times the performance per socket. It's probably even higher than that. That's just what they can blatantly say. Now, they didn't talk about clock speeds at all for EPYC, which also indicates that's why they're saying 2 times the perf. Is they probably like, well, we can for sure hit the same clock speeds, but can we go higher? They don't want to over pronounce that, because I wouldn't be surprised to see 2.5 times the performance because of the die shrink and the IPC improvements and the probably clock speed improvements. So, now, it's very interesting to me how different it looks, and that they've kept it socket compatible, and that we're seeing 8 cores per Zen die. Which we did see, on Threadripper, we saw 8 cores per die. But this makes me wonder, so the dies are a lot smaller, so they could fit 2 of these dies very easily onto a smaller AM4 chip if they can make that socket compatible, which, considering they have here with double the dies, I imagine they could do it with Ryzen and AM4 as well, especially if that center bit is some sort of controller, which they could fit in there as well or something. Wow is really what this comes down to. They did a benchmark developed by Cray's benchmark, and a single socket Rome chip was capable of doing, the benchmark was in 28.1 seconds, whereas a dual socket Intel 8180M, that is their 28 core super high capacity chip, did it was 30.2 seconds, so faster than what Intel has. Of course, you have more cores because you're looking at 56 cores instead of 64 cores, so there is a difference there. So that still points towards Intel having a single core and a clock speed advantage, maybe, or an IPC advantage. But of course, a lot of the performance stuff is still in early stages. It's air cooled as we expected, and probably they say 2019 for sure they will be able to. These will be out shipping like crazy. They're sampling now, though, as we mentioned. So now to get into some of the Intel news, I want to first reference back to Threadripper 2 when it came out, right? At Computex. The day before Threadripper 2 came out, Intel announced a 28-core 5 GHz CPU. Now, we all know the 5 GHz stuff was crap, and everybody crapped all over Intel for that because it was bad marketing. But it was a 28-core overclockable enthusiast-class CPU on the massive 3647 socket, LGA 3647. Really cool-looking chip, actually, for enthusiasts, and was beating AMD because AMD only had 16 cores on their highest-end platform. And then AMD, the next day, announced a 32-core. So, yesterday, Intel talked on their server market about having a 48-core chip. And today, AMD talked about a 64-core chip. Now, I wanted to say something to anybody working at Intel that's watching that I thought was interesting. Do you realize that it's actually worse to announce that you have a worse product beforehand? Like, you would actually be better off waiting for the 64-core to come out and then saying, well, yeah, but we also have a 48-core now. Saying it beforehand literally is like, AMD, steal our thunder. Like, I don't understand. Like, you're like, oh, let's talk about this amazing thing. It's only a day, Intel. It'd be different if it was a month.
Yeah.
That could affect your stock, all kinds of other stuff. This was a day. You announced a 48-core chip. People went, wow, they're putting massive amounts of cores in chips. And then my first speculation when I saw that, my first thing that came to mind is AMD's releasing a 64-core chip tomorrow. Because Intel, of course, all these companies have insider information on each other.
Yeah.
I'm sure Intel did this to try and steal the press, but doing it earlier when you have the worst product isn't the best route to go.
Yeah, and when you have a singular product announcement versus a big event that a bunch of industry is going to,
yes,
you're not going to steal the press cycle. You're just going to lose it, which is what happened.
Exactly. Everybody's going to forget about this 48-core Intel now.
Yeah. I haven't seen pretty much any discussion today online about it.
Yeah, nobody on Reddit's talking about it. Nobody in forums are talking about it because why would you? Something better came out the day after.
Yeah.
I don't understand. It's like if Apple was like, here's the iPhone XS, and then a day later, here's the iPhone 11. Nobody's going to pay attention to the XS. What's the point? But if you release, here's the iPhone 11, and then you release, and here's a cheaper version that's blah, 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 or something.
I mean, that's what they did with the 10Rs. They purposefully released that a month later.
They did.
It was genius.
Yes, it was great. It was like, here's the worst product, but it has a market segment. The problem is everybody focuses on the top, whether or not you can afford it. Everybody focuses on the top.
Yeah.
So you release the top first, and then you release the other stuff later when people have calmed down from the hype of the top and go, okay, look at this logical thing.
Yeah, I guarantee that if Apple would have released the iPhone XR at the same time as the XS and XS Max, the XR reviews would have so many less views.
They would, yeah. Nobody cared. Nobody cared because everybody's focused on look at this new, awesome, amazing, incredible thing. And so Intel's making a mistake here by having what is, I would say, especially in this case, a worse product. The 28 versus 32 cores, Intel had a clock speed and an IPC advantage further than they do with Zen 2. Zen 2 might even be equal or beating. Who knows? We can't judge that yet. But that was a little more like maybe understandable. But now Intel's far enough off in the core count that clock speed and stuff like that isn't going to make up for it.
Yeah.
And then you also have efficiency improvements on Zen 2 because it's 7 nanometer. So EPYC's going to be winning on that front, at least until 10 nanometer comes out, is my assumption. And of course, AMD's just gluing dies together. So, it's just, Intel has these single monolithic dies that are really big, and that's why they don't have the issues of like Infinity Fabric and directly connected memory, except that the 48-core Intel is exactly that. It's two 24-core dies hooked together.
Why couldn't they do 228?
I don't know. Some people are speculating that there were some potentially like thermal dissipation issues and stuff like
Probably.
that. So it might even be 28-core dies with 4 cores disabled. Who knows? We need to wait for like Der Bauer to get a hold of one or something to test that kind of crap. Yeah. So they're literally doing what they criticized AMD for just months ago.
I mean, that's like most Android manufacturers and the headphone jack.
This is true. That's a good point. Hey, we still have the headphone jack. Next phone, we don't have the headphone jack. You bragged about it last year.
Like, OnePlus is one of the only companies that I feel like has a good excuse.
Yeah.
Because with OnePlus, we're losing the headphone jack because we wanted to keep our prices cheap, and the way we do that is by not designing our own phones.
Exactly. And they didn't want to use one of the other Oppo chassis that aren't as nice.
Yeah.
So I definitely... that's more a good excuse, right? And that's akin to this, though. Yeah, you're right. They're just... I'm dumbfounded. I'm dumbfounded. Now, of course, Intel's like, well, yeah, but our interconnect, I don't even remember the name of it. I would have remembered the name of it if you had talked about it a week from now. I wouldn't have forgotten. But I'm sorry, you talked about your interconnect yesterday. I read about it and said, that's an interesting name and looks interesting. Oh, it beats Infinity Fabric. Wow, that's impressive. And then Infinity Fabric Gen 2 comes out. I don't even care about it anymore.
Yeah.
And it's frustrating because it might even be better than Infinity Fabric 2. I don't know. But... the way you launched it, I'm not remembering the name of it, but whatever it's called, they claim it's better than the original Infinity Fabric. Who knows about IF2? Now, that could help with a lot of stuff. Intel's really good about multi-socket stuff, too. They've been very good about the way that works with memory. So...
see, what I'm surprised about, because I'm not surprised that ultimately Intel chose to copy this. I'm surprised they were able to do it this fast.
So that's
even though they haven't released the product yet, they're at the point where they are comfortable talking about it. I expected it to take them longer.
Yeah.
Than a year
I would
and a half.
too. Now, the one thing that helps them with that is they already have their, I think it's called EMIB, which is their embedded memory interconnect bridge, I think is what it is. And that's where they have their multi-socket. That's why you can have up to 8 sockets with Intel.
Yeah.
And so they already had something that could communicate between stuff. And so they probably are using that same ideology, just applying it to a single package.
That makes sense.
But a couple things to point out here is, first, that 28-core from Intel that we talked about prefacing this whole thing still can't be bought.
Yeah.
So who knows how long this 48-core is going to take to come out. But... also, pricing, of course, is another thing. How freaking expensive is a chip like that going to be? And also, because there's no die shrink, it's over 5,000 pins. It's like 5197 pins. That means this is literally going to be a bigger socket, we can assume, judging by the pin count. Of course, pins can change size and stuff. But this is very likely to be a bigger socket than TR4 or SP4, which, same thing. But, and like already, LGA 3647 is massive. Not as big as the 4096 pin TR4 platform, but this is probably going to be bigger judging by the same pin sizes, so they don't even have that advantage anymore. And one of the big things Intel had was they could have up to 8 CPUs, 8 sockets shared on a board. They could do that. It was more common to see 4, but they could do up to 8. Yeah. Because of the way this works, just like the way EPYC works, you only have 2. So you're still stuck with the same situation where it's like, okay, now you can have 128 threads, or 128 cores, or you can have, I'm not mathing right now, 96 cores.
Yeah.
So, like, it's just dumb.
If you needed a lot of cores, just get the 28 core if they ever release it on an 8-socket motherboard.
Yes, exactly.
Yeah.
Because the multi-socket interconnects, that can be more dense for a board. And that was something I talked about when EPYC 1 came out, is I was like, Intel still has an advantage in that respect because you can fit more in that section. And so you can actually fit more compute power in a smaller area if you're going like super ham, whole hog, as you put it.
Yeah.
So I don't know what Intel's doing at this point. I want competition, right? And I'm glad AMD is doing such a good job competing. And don't get me wrong, I'm glad Intel's being stupid because it's giving AMD a chance to take back that market share. And I just hope Intel doesn't continue being stupid when we start to see that market share get closer and closer to that 50% mark. I want Intel to fix all their dumb things they've been doing.
Yeah.
Maybe the new CEO is going to help with that some. I don't know. But it's just this and the 28 core and the way you've been marketing stuff is not impressive. And then the 10 nanometer will come out next year, 10 nanometer will come out next year, 10 nanometer will come out next year, 10 nanometer will come out next year. I could do that 3 more times before I would be done. Like, nobody believes you. Nobody believes you. Even the people that understand CPU architecture are like, I'll see it when I believe, or I'll believe it when I see it.
Yeah.
So, sad face, I guess. And it's kind of unfortunate, but of course, Intel does still have long-term partnerships. Server market takes time to change.
Yeah.
And there are companies, there were Intel, like the negotiations that go on when you're ordering 50,000 CPUs are very different from ordering just a server. Like if I were running a business that needed a pretty high capacity server, unless required by software, which is another problem that Intel has, they have a good software proprietary market. But even though it'll run fine on AMD, they won't support you, right? That kind of thing. But if I could, I'd go with EPYC because it's just better for the money.
Yeah. Yeah, because I mean, like, realistically, if somebody like Amazon wanted to know Intel's future product stack so that they could
judge what they're buying,
and then like plan ahead, Intel would tell them.
Oh yeah, absolutely. With a client that big,
yeah,
you give them insider information all day long. You all day long, man.
What's that? You want this info? Sign this NDA. Here's it all.
Yeah, exactly. That's what it would come down to. And so, judging by that, maybe what Intel has packed in the future isn't that great because Amazon and Alibaba and Alibaba, I always say Bob, Alibaba and Baidu and Tencent and all them are big enough customers, but especially Amazon, that they probably are like, okay, no, we're going to go with this instead.
Or what if...
Or the price differential is just big enough.
Or what if something, Intel has something good planned, but it's long enough out, like, let's say it's like 2-3 years out, that 2-3 years of EPYC is worth it.
That could be too.
Yeah.
That could be too.
And
also...
for Amazon, having both of them compete for Amazon specifically...
It's just like what Apple tries to do with SSDs and the like, is like, now we get the best prices. So that's a smart move on Amazon, although I'm scared of Amazon. Yeah. And also, of course, knowing what AMD does for longevity rather than just make more money, that's another incentive for even the data center is, we don't have to buy new boards? Cool.
Yeah.
And then, of course, you'll see a bunch of 64-core EPYC CPUs on sale for $600 on eBay. So, actually, I would expect like a year or so, maybe 2 years from now, you'll start seeing EPYC 1 for real cheap on eBay. Yeah. If you need a rendering server or just a general like workstation box or a cheap server or something like that, keep an eye out for used EPYC stuff. Yeah. Definitely.
So jumping back into more AMD news.
I'm sitting back into AMD news. So Shasta, the supercomputer that we talked about last week, and a lot of you guys apparently liked our AMD news video when we talked about supercomputers, so a lot of you probably seen that. Shasta is this new supercomputer by Cray using EPYC. Really awesome. AMD talked about it. Cray primarily talked about it. Well, Cray actually was at this event. They got up on stage and talked about it more. Now, they basically resaid stuff we already knew. 100 petaflop performance, $126 million contract using EPYC CPUs. But what we know now is EPYC 2 is good enough. And that's what we didn't know when Cray announced that. And I actually didn't even speculate that, which usually I'm fairly good at speculating things like that. But I didn't even speculate that they were talking about EPYC 2. But my understanding is I bet they are. I bet their EPYC 2 is good enough. Now they're like, let's build a supercomputer. So that's all really impressive. And then I wanted to talk about Rock M 2.0. It's a software ecosystem. This is going back to GPUs.
Oh, it is. I thought it was like Rock'em Sock'em Robots.
Well, you could do that with like GPUs in their hands.
That would be awesome.
We should make a meme, or somebody should make a meme. So if I see that on the internet on like AMD or something like that, I'm gonna be like, I came up with that.
No,
and by I came up with that, I mean you.
The only thing you're allowed to comment on that is that this is epic.
I love it. I love it. So, Rock M 2.0 is their software ecosystem, the second generation. It's all open source software. It does work on NVIDIA GPUs and Intel's CPUs. So that's interesting, saying CPUs, and assuming Intel's GPUs whenever that eventually happens. And it's included with the MI6 GPU. It's not a separate software package or a separate license. It's compatible with Dockers and Kubernetes, and it's upstreamed for the Linux kernel. And they're working with Google on TensorFlow integration and Facebook with Cafe/PyTorch. And who cares about that? And then more importantly, Baidu on Paddle. Funny name. Now, I'm going to be straightforward. I don't know much more than what I just stated there. Software is not my specialty.
He said a lot of words.
I said a lot of words, but software is not my specialty on these things, so I don't fully understand. And they didn't give a lot of details, to be fair, but I don't fully understand what the point of this is. Like, I don't know what this does, you know what I mean? Like, Radeon Open Compute, but, like, what is it? Blah. More heterogeneous compute. Okay. So, that still doesn't help people in the audience, I suppose,
No.
because that's still, like, confusing. It makes a little more sense to me now. Again, it's just, I'm very dived into the hardware ecosystem. Software stuff sometimes on the epic level like this confuses me a little bit, but it's really cool.
Essentially, to sum things up, I'm just gonna read the one line of text.
This is from GPUopen.com, which is AMD's thing.
So the ROCm platform brings a rich foundation to advanced computing by seamlessly integrating CPU and GPU with the goal of solving real-world problems.
Okay, so it really is a focus on heterogeneous, which is something that AMD's really been a pusher for, is CPUs and GPUs being able to work together more seamlessly and being able to function more like one unit, where you have a set of they actually did it with their excavator-based APUs, where you had RAM and you had cache, and the GPU and CPU shared RAM and cache, and then they were able to kind of the idea was to dynamically toss things to the right thing for the job, either a GPU or CPU, depending on what's necessary to make sure it gets done at peak efficiency. And for the very few things that we were able to test back then, that was like 7 years ago, it did very, very, very well. And so I guess this is more of a focus in that direction, which is cool. I think it's a very long-term play, though. I don't expect anything incredible to come out of it yet, but also working with Google and Baidu on stuff.
Yeah, I think it's going to be very useful for AI.
Which makes sense, and it's cool because AMD needs to compete in that area because
we're still seeing
NVIDIA is like the only one there right now.
Yeah, while it's like in general the idea is like Tensor Cores, GPUs are better for AI, we're still seeing certain AI things processed on CPUs.
Yeah.
And so if we can have a platform of software that's designed to handle GPU and CPU AI processing together.
Yeah, that's a good point. That could be a really
for more
big deal
complex
there.
AI, that can probably be the game changer.
That could be. So a long-term play, I guess, again, is what it comes down to. And it's cool stuff. The hardware is what blows my mind more. And then our last little bit of AMD news for that massive, it's been almost an hour section, is Lisa Su was appointed the first chairwoman of Global Semiconductor Alliance. We were going to put that as one of the big topics for the week, and instead it's literally a single bullet point.
Yes.
Because EPYC was so huge.
Yeah.
I didn't use a pun, you're welcome.
Thank you. I mean, you did kind of. It is large.
Huge. So, any more information regarding this, though? It's just like a basic, she's the chairwoman, which is really cool. I mean, I think she's fitting for it. And
I don't know what
cool.
the Global Semiconductor Alliance does.
So it's basically the semiconductor companies being able to work with each other.
Yeah.
On things like IP. So
collusion.
Yeah. Okay, I was right. Yeah. Jensen Huang. I think I said that right. I'm trying to get better at that sort of thing. And Lisa Su are they're relatives. So we always bring that up. So they're colluding anyway.
Does this make her his
They're
boss?
colluding to
No, I know it doesn't.
No, it doesn't, because this is semiconductor. I don't know if NVIDIA is part of this. Although,
it's supply chain related mostly,
So probably not. It's
Yeah.
TSMC, Global Foundries, all that kind of stuff.
Yeah.
It's cool that she's a part of it, but I think she's fitting for the job, maybe.
Yeah.
Although, should she be taking on a heavier workload?
So generally, when it comes to alliances like this, being the chair isn't a like super demanding thing.
Oh, that's a good point. Okay. I didn't really think about that much.
Yeah.
Yeah.
It's something you have meetings for regularly, but outside of those meetings, you don't do much, I think.
So do you think Jensen and Lisa are working real hard together to destroy Intel?
No.
Why not?
Because.
They don't sit down at the family dinner table over a duck and talk about...
No.
Oh, okay.
No.
I said duck because that's what rich people eat, right?
No.
No? What do rich people eat?
Solid gold.
I do that all the time.
No.
I don't?
No, I've never seen you eat solid gold.
Is it fake gold then?
I've never seen you eat gold.
I said fake gold. That's not
Okay,
gold.
I've never seen you eat something that looked like it was gold.
I ate some chips earlier.
Those did not look gold.
They're gold colored.
No, they were not.
I thought they were pretty epic. So, whew, did I ruin the podcast?
Yeah.
Okay, so anyway, we're jumping into some other news here, though. So more medium-sized news, and then tiny news. Also, we've got a couple of interesting things that we'll talk about there regarding Smash Direct and also the Free Music Archive. So it's kind of interesting.
Yeah.
But this is about Facebook.
Oh man! So as we do, it seems like we're gonna have a weekly Facebook controversy section almost.
So what I'm understanding here is Facebook did a whole bunch of good stuff. They're protecting user data better now. They are not selling the same ads. Oh,
No.
okay. It's not that?
No. So.
Is it an improvement?
So.
I didn't read this, so I'm actually
Okay.
I don't know.
So essentially what happened, after all of what happened during the last election, as far as Facebook, political ads, interference, all of that.
Yeah. And just not even just political ads, but ads in general.
But yeah, but this is specifically about political ads.
Okay.
Essentially, there was an issue brought up of political ads being paid for by one person, but under the claim of being paid for by someone else. So I could make an ad with you saying that you hate net neutrality, paid for by you, but you don't hate net neutrality.
And it wasn't
and you
paid
wouldn't
for
pay
by
for
me.
that. And so Facebook...
So that's a
huge issue.
That's a very big
and so
issue.
Facebook,
because then you don't even know what people stand for. Like, it's just...
Yeah.
It's
and
literal just lies. Which,
so Facebook was trying to deal with stuff like that by implementing something that would... they would actually verify who paid for ads. Like sending letters to people's addresses, that type of thing. We discussed some of this stuff before.
We talked about this separate from the podcast before.
Well, we talked about it on the show before too.
Did we last week?
No, a while back.
Oh, a while back.
This was a change a long time ago.
Okay.
And so, in doing so, the idea was that you shouldn't be able to pose as someone and post an ad claiming to be them with the ad saying with Facebook's label paid for by them. Yeah. So Vice tested this.
Good on you guys for doing that.
Specifically, they went through and attempted to get approval to post ads, and they tried to do this as all 100 senators in order to also ensure that this wasn't like helping one party or the other.
Yeah, okay. And did they actually show any of the ads? Like, did they have pictures of them and stuff? Some of them,
so they did not buy the ads. They just went through the process to get approval.
Okay, so in that case,
at any point, no. So once you get approved,
what were the ads like designed at that point though?
I don't know,
because I would think like if there's something where it's like this was Senator Ron Wyden, like until the ad's created, how do they know you're posing as them unless it's just like a form you fill out saying this is me?
Yeah, that's what's supposed to happen. Is you get to the point where you are approved to post these ads as them, and then you can just do the normal ad process.
Okay.
As you. And they got approval, not as like some or most, literally all 100. Facebook didn't catch them once.
Posing as senators.
All 100 senators. So literally Vice could have posted ads claiming to have been paid for by all of these senators. With whatever they wanted.
Facebook's a great place. You should go there for your news, your information.
Mm-hmm. Click on the ads.
It's so bad at this point. I almost feel like bad joking about it because what if somebody hears that out of context and does it?
Oh, we're not done. Business Insider also did a test. Business Insider posed as Cambridge Analytica.
Okay, you did tell me about this one, and I was like...
They posed as Cambridge Analytica, was verified to post ads stating that they were paid for by Cambridge Analytica, and Facebook was going to allow it. Facebook hasn't banned Cambridge Analytica, and also failed to catch them as their own company.
I don't even understand. How is it that bad? Like Facebook, do you have... Is it really just Zuck and an AI running your entire company? Like, is that it? There's no other employees? Like, you call to get a hold of somebody, it's actually just the best AI talking on the phone ever?
They're hiring Google Duplex.
Yeah, exactly. Because I'm just sitting here like, how do you... And aside from that, if your AI is that good, why are you not screening stuff? Like, I don't even understand.
Yeah.
Like, and then wasn't there somebody that, like, posed as a terrorist or something, too? Wasn't that a thing?
I did not hear about that.
I think I heard about that somewhere. Maybe I'm wrong. Maybe I'm remembering wrong really badly somehow. But I think there was somebody that, like, put up, like a pro-terrorist ad. And, like, they, like, or attempted to. Yeah. And they were posing as some...
So, with that... I actually think that that's a little bit different of a situation because while that is extremely bad, there is not that same level of pre-verification process.
Okay, so true.
If they write the ad in such a way that it can bypass any initial AI screening, that would just happen on all ads posted on Facebook. Yeah. It would come down to user reports to block that ad.
Oh, that's
Whereas with all of these, they're supposed to be verifying identity because the paid for by part is the important thing in the situation.
Okay.
And Facebook failed.
So this is why you guys should continue to use... You know what? This makes me genuinely angry. Facebook makes me genuinely angry, but the public makes me genuinely angry. The lack of the public to react to such a big issue. It's like, the public's totally fine with roaring out and fighting with each other about huge political issues, about... things as far as the trade war with China or whatever it may be. People are okay with yelling about that. But when a company does something this horrible, many things this horrible, over and over and over and over again, and they're not even having money problems. They're not even having user base problems. And I don't understand because there's competitors out there. There's Twitter as one.
So let me say this. A big part of the problem is that there's two big problems. With how big Facebook is, naturally, they're going to grow at a rate that is probably about on par with what they've been losing in customers, so they're probably just gaining less. On top of that, there has been a lot of reports that they did see a decent drop from younger people who follow technology more.
Okay.
But they're seeing more gains in older people, in people that are having kids.
Other countries.
India
is blowing up right now in terms of the internet.
But it's like, you still have a lot of, like, let's say with just talking about the U.S. specifically, you have a lot of the people, as generations have been having kids a little bit later. Yeah. You're having the people, like, let's say they're 30s right now, that are having kids wanting to post and share those pictures with, like, their grandmother or their mom. Easiest way to do that is post it on something like Facebook where you can send it once, share it to everyone.
And a lot of people don't take the time or maybe even have the time to look for a competitor or something like that or try something else and then force all their friends to get on it. That's a lot of effort. It's not like it takes a long time to sign up for like MeWe or Twitter or something like that. It's getting other people to use it.
It comes down to something similar to like iMessage, for example. Yes, they haven't had the controversies, but like I was listening to the WordCast and Nilay, one of the people on there who runs The Verge, he was talking about how, he just had a kid and while he would like to go to Android, switching off iMessage when that's how he sends the like group pictures to his family about his baby. And he shares the photos through Apple's photo app. Yeah. And while he'd rather switch to Google Photos because of a lot of different benefits. Yeah. It's like when you're integrated into these platforms with
you get locked in and it's hard to leave. Yeah. And another thing though, I don't know. And business is another thing too, right? Is I work for a marketing company. That's one of my jobs, and it's like Facebook's a huge tool for a marketing company, and for businesses doing self-marketing too, if they're not hiring a marketing company. And so it's it's complex, but also I feel like it's an integrity thing. I left Facebook completely because I just couldn't stand them. And after some of the bad stuff, like I quit them for a while. I deactivated my account for 6 years, got back on it for about a year, and then just full deleted my account because, and I wasn't even having like social media addiction problems, which is a whole other thing that we can talk about. I know some people that are in that kind of a situation. I know various people that will leave for a week or two and come back, whether it's Facebook, Instagram, Twitter, Snapchat, whatever it is. And it's good to take breaks too. I get that. There's a stance there too. But I just feel like with Facebook, it needs to be an integrity thing, is we need to not stand for this sort of stuff. And Equifax is another example. Now, they're harder for consumers to leave. But you all have the option to delete your Facebook account. Yeah. And I think the right thing to do is to not let them get away with this. And you know what? I guarantee you if enough users left, Facebook would work on it. Yeah. But they don't care right now, because if it's not affecting your bottom end, why care? It's just like Equifax. Why fix your security when the fine costs less than fixing your security? Yeah. So... I
mean, there's a reason that even Mark Zuckerberg said that industry probably needs to be regulated.
Yeah.
Because it's something that by its own nature locks you in.
Yes, the only reason that things like Twitter exist are because they're different. Yeah. They're social media, but they're different. Instagram, different. Even though it's owned by Facebook now. Yeah. Snapchat, different.
Yeah. When you have social networks that ultimately compete on feature set and the way that you use them, so much like Facebook and like MySpace used to. Yes. Naturally, eventually... you're gonna you might pick here and there
with social stuff specifically. You're more so than any other industry.
Where your friends are.
Yes,
because that's the most important aspect of the social network is the social networking.
So one will win eventually, and that's it's a quicker process and a guaranteed process with social media versus other industries where there's competition, monopolization, only a few players, things like that, where it doesn't always come down to one player. Oftentimes there's enough competition. Look how bad AMD had it for so long, and they managed to fight back. But that kind of stuff, you don't come back from a MySpace failure. Yeah. You don't come back from that. Yeah. And the only reason that like something like MeWe isn't popular, even though it's completely ad-free, it's free to sign up, all this amazing stuff, it's a great platform, is because it's competing on all the same feature sets. Now it has more features, but the primary features of it are very similar to Facebook, and nobody's going to move to it because I have Facebook. Why would I set up a new account? And it's like, well, for one, because it loads faster and has no ads. I think that's right there. No ads is a very nice thing because people use ad blockers and stuff, so you might as well just not have them so you're not wasting time and resources and battery life, because ad blockers affect that. But it's because it's that same feature set, nobody's going to migrate to it. Whereas Twitter, being a completely different thing, is hugely popular. Yeah. And so I just want to encourage anybody watching this, please go delete your Facebook account. And if you're worried, people don't have another way to contact me, right? Spend a month. Post twice a week. I'm leaving Facebook on this date. If you want to get a hold of me, private message me. Or if you're comfortable with it, if your privacy settings are good enough, here's my phone number. Yeah. So that way people can get a hold of you. Or here's my Twitter handle, or whatever it may be. Delete your Facebook, delete your Instagram. I did that too, especially because the CEO's just left.
Yeah. Actually delete it. You can always make another account. Yes. Save your archive before you delete your account. That way you have all of that if you want those older posts.
I forgot.
Oh, yeah, you should have. Oh, well. Save your archive. That way you can access those posts if you want to go back and look at that stuff. And then actually delete your account and only sign up again if Facebook makes the appropriate changes.
Yes, yes.
Reward them for doing the right thing. Punish them for doing the wrong thing.
I agree with that completely. And I will do my best to remember to put a link in the description of how to get your archive and how to delete Facebook. Yeah. It's very hard to get to the setting to delete Facebook. The best thing is to use a direct link. Yeah. So I'll include that as well if I remember. I'll include all three of those links. Yeah. I think it's good that you and I both are not part of Facebook. Yeah. So now into tiny news.
Nope.
No.
I said I had another topic.
Well, crap. So, okay, another interesting topic.
Yeah,
Oh,
so
okay.
the FCC is making no longer a request, but a demand of carriers to implement proper caller ID authentication by end of next year, essentially. And essentially what they're saying is that if this does not happen, they will implement requirements.
So this is a good thing.
Yes.
So EPYC did something good for once.
Yeah. Now, that being said, realistically, this is something the industry is probably also pushing for the most part.
Yeah, because it's a problem.
It hurts the industry. It hurts
everyone. It hurts
everyone.
them directly and everybody else, too.
The only people it doesn't hurt are the scammers.
Yes, and even then, it can because they get caught a lot of times. So, but I mean, obviously it's not this, but the aspect of being capable of doing this gives them an aspect of crime to go towards. They'll go towards something else, probably. Yeah. But, and it's a big problem to me for elderlies that maybe get a spam call and don't understand that that's a robot speaking to you, and and especially because they've gotten it's actually kind of hard to tell sometimes now, and they end up giving a bunch of money away or giving them their credit card or something like that. You have people that just generally don't have good education or knowledge on that sort of thing, and then of course you have a really big one is there's a nuisance for people, but a nuisance for businesses. It's a big problem when you run a business and you have to answer your phone every phone call you get because it could be a customer. At my business, we get international customers. So even if the number's weird, you have to answer it.
Yeah.
That's interrupting your day and potentially interrupting other calls. And it's 50 to 80% of the calls every day are spam calls.
Yeah. It's to the point where it's causing significant network capacity issues. And it's like, carriers for a while made a big, and they still with like Verizon's 3 tiers of unlimited data, they make the big deal about bandwidth. And when they're taking up significant amounts of bandwidth on pointless phone calls.
Yes. And for those of you, I know there's going to be some people out there going, but it's voice traffic, it's different. Not anymore. It's all voice over LTE. So it is genuinely affecting your network speeds.
And then on top of that, it's been such an increase in call volume that it started just in general making a network available frequency difference.
Yes, which is insane to think about. It's a big problem. I think it's one of the bigger tech problems that this country's facing right now and that the world's facing, really. It's not just a U.S. thing. I'm glad, though, that the FCC is doing something about it. And this is a good move on their part.
Yeah, they've literally said that it is the top priority.
And, how do you feel? Is this a higher priority than net neutrality? No. I mean, obviously, their priority than net neutrality is not even on the radar.
Is a free speech issue for me. So
yeah. No. Okay. But I think
because
this is probably right
carriers
after
need the ability to edit websites because that's free. No.
So, but this is probably issue number 2 then. Yeah. Of the internet as a whole in this country. Yeah. And maybe the world.
Things that would be classified under FCC. Yeah.
Yeah, I agree. And so at least they're doing the right move this time. Hopefully it leads to stuff, but I think it will because I don't think the companies want it either. And T-Mobile has pushed out what I've noticed. It seems a little different now. So you a lot of times get scam likely as the caller ID when it's likely to be a scam, but they are also doing nuisance likely now too, which is something I saw for the first time today. Yeah. Maybe that's not new. But I think the industry is pushing in that direction.
One of the other things when it comes to these robocalls that we've been seeing is because they so often spoof caller IDs from your area, we're running into the issue where if you block the spam calling numbers that are showing up that don't actually block the people from calling you because they're spoofing the number, you're blocking a random person. And so there's actually been a few reports now of people having supposed to have gotten a phone call from a client or from someone that they met.
They don't get it because
they don't get it because they have the number blocked.
Oh, that's I actually hadn't even thought about this. That had not crossed my mind.
If you block the number that's showing up in your phone, you are blocking a random person.
Yeah, not the company.
Yeah.
Now, of course, that's if it's a number that's clearly spoofed. So maybe the suggestion would be if it's a number that's clearly not a spoof number, but that's not your
But then
area.
what happens if they just start spoofing Texas for Oregon calls or spoofing California?
Okay, that's true.
Or Washington.
But then you're blocking people that are less likely to call you.
Yeah.
But still, and so it creates an issue.
With how much people have moved around the country and whatnot, it's
still
ultimately
an issue,
the area code and stuff is only a general thing. It's
Yeah, people see that and they're more likely to pick up.
Yeah.
And they also commonly will spoof your second 3 digits as well. Your area code and then your second 3 digits. Yeah. And so you go, oh, that's weird. And you want to pick it up, right? First time it happened to me, I actually did answer, and then I stopped after that. But and like the calls are getting to a crazy extent because it's not just asking for money or saying we can lower your credit score or blah blah blah. I had one that happened. I think it was 20-something times in a week. The same phone number calling me, leaving the same voicemail about me being sued. And I'm just like, and of course it's BS, but I'm just like if I didn't know better, that could really scare somebody, and they might call back and try to do something about it.
Or the IRS ones.
Or the IRS one, which I've had before. This one in particular made me mad because it was the same number multiple times a day, voicemail each time. That was really annoying. But
and see, the thing is that if you would have blocked it, then that's probably when they would have used a different number.
Probably, yeah. I also want to recommend to people, there's an app out there that generally does a really good job. I haven't used it recently, but I was using it, and it did do a great job about a year ago, called Mr. Number.
Yes.
Very good at finding, blocking spam calls and spam texts.
Yeah, when I worked for customer service for a cell phone carrier, that was also what they had us recommend.
Okay, very cool. I've heard a lot of people recommend it. It worked great for me. You can do some modification and stuff too, but the app itself is really good with a database of this is probably a spam. Yeah.
Speaking of spam texts, by the way, if you get a spam text that says, like blah, 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 random spam stuff, reply stop to stop this. Do not reply stop. All that does is confirm you have a cell phone that they can text.
Yes, and obviously never respond like yes or something.
Yeah.
Because that's something that the spam callers will try to do too if you get a phone call, is they want you to say yes on the phone. So they'll be like they'll call your business and be like, oh, is this blah, blah, blah? And you say yes. They have a recording of you saying yes. They'll sign you up for a contract. You can get out of it, but you got to pay a lawyer and go through the process, and it's a big problem. And they try to set the amount that you can pay to get out of that sort of thing low enough that you'd rather do that than go through the lawyer. And so that's another issue. So Mr. Number is great.
Yeah.
And also, if you see a text that you're pretty sure is spam, like you're not like in the middle, best to just delete it. Don't even open it, because there could be something quirky like special characters that cause a crash on the phone.
Yeah.
Those usually get fixed, but there could be stuff like that or viruses in multimedia messages, things like that.
Yeah.
So now moving on to tiny news.
Yeah, we've only got really one thing for that.
We got two. We got the one additive. Yeah.
So Nintendo held the final Super Smash Brothers related or specific Nintendo Direct. They announced a few things. Ken was confirmed as a character, and Incineroar, the Pokemon, was confirmed as a character.
Cool.
And that rounds up that ends the roster for the actual release of the game next month. 1 month
Exciting.
and 1 day.
Yeah.
And so that puts us at like 70 characters at launch.
A few.
Yeah, for a fighting game, that's insane.
That's so many. That's so many mechanics and stuff. It makes things so complex.
Yeah. And then they've also confirmed that if not pre-order, but just if you buy the game before January 31st, almost 2 full months after the game comes out,
really awesome,
you get Piranha Plant for free when it launches in February.
As a playable character.
Yes.
Which is like the coolest character in all of Nintendo's universes is Piranha Plant.
Some people are actually really mad.
Why?
Because it's Piranha Plant, not PD Piranha, and they're mad that Nintendo's using a generic character instead of a named character. They feel like it's somehow copping out or taking the easy route.
But I don't think it'd be that much harder to do.
You still have to make all the mechanics, and quite frankly, PD Piranha is not that interesting compared to Piranha Plant. Piranha Plant is interesting because there's a lot of different things that have to be designed around a character in a pot.
That's a good point.
Yes, he does move because he has feet, which is actually realistic to Piranha Plants in some games. But he still uses that pot, and he still does movements that are specific to Piranha Plant, like extending his neck really far, that PD Piranha wouldn't do.
Yeah.
PD Piranha would just play like another character.
Yeah.
So I actually really like this.
I think it's a unique thing. I
want this, I want Shy Guy, and I want Boo. Those are the Shy Guy and Boo I've been asking for years.
I've been in complete agreement with that. Even I'm not a huge Smash fan, but even now, I still really want that. And when I was a Smash fan, that was Why? Why no? I don't
Yeah.
understand. You could do so much with those characters.
On top of that, they've confirmed 2 other things that are really important. No more trophies in the game. Some people are really bummed about that, but quite frankly, it was a lot of dev and art, mostly art time, to make full 3D models of hundreds of characters from different games.
Yeah.
And then also writing like a paragraph about each character. It
That's
came
a
out
lot
to
of
like
time, yeah.
10,000 something. It's like a lot.
It's
of work.
expensive.
Yeah.
I mean, realistically, with a game this big, they can afford it. But
Yes.
I'd
But
rather
what
have
they're-
the money put elsewhere.
What they're doing is essentially something similar, but that takes less work per character so that they can add mechanics to it and make it an actual gameplay element.
Okay.
So what they're introducing is something called spirits. And what those are is for the single player and certain multiplayer modes where you have this chosen to be enabled, you get essentially what are like stickers of different characters that have actual stats. So it's more like an RPG where you're picking, like in RPG you would pick your armor that affects your stats, gives you different abilities. This does that.
I like it.
And then they have a new game single player mode that is relevant to these spirits, because what happens is there's an awesome cinematic that everyone should watch. It's essentially like
I'll try to link that. That should be in our source
like
links.
Avengers Infinity War type, like all of the Smash characters up against one big bad, and the big bad wins. It literally kills everyone but Kirby. And turns them into spirits that Kirby then has to save.
Because you can't kill Kirby.
No, Kirby's literally OP.
Kirby is... Yeah, by the way Kirby's built,
Literally,
Kirby can't die.
the reason that Kirby survived this was because Kirby traveled faster than the speed of light and teleported.
Yes, because it's Kirby. Anybody that's followed Kirby closely and like watched a lot about it,
Kirby's a god.
Kirby is OP.
Kirby is still considered a kid.
And we're not saying OP in the game, but like OP as a character.
Kirby is still considered a kid, and Kirby is actually like a god of the Nintendo universe, essentially.
Yeah. Everybody, all you guys saying Superman's the most OP thing ever.
Kirby can crack planets in half by just like hitting the ground.
I mean, he can also swallow a planet.
Yeah.
Which, I mean, that alone, being flexible enough to do stuff like that is like, how do you kill it?
Yeah.
It's like trying to like beat up rubber
or water.
Yeah. Yeah. Like it's not gonna No, it just displaces.
Yeah. So I think that the spirits mechanic is really interesting.
That's interesting.
I think it's going to be really good for the single player aspect of Smash, which I do think that while Smash on the Wii was good for the single player, I don't think that it's been good in most any other Smash game.
Yeah, okay.
I'll say Smash 64, for its time, it was good.
See, I didn't play the single player on that, so it's hard for me to know. I played the game, just not the single player.
I understand that. We need to fix that.
We should fix that. And then our final news topic of the week that touches my inner data hoarder. The Free Music Archive is done for. Now, it doesn't mean that the data's gone forever. But they put out a blog post, if I can get to it, because apparently I put it way far back and their site's overloaded right now. So Cheyenne H posted this on yesterday. Today's the 6th. Posted it on Monday, November 5th, 2018. Big changes ahead for FMA. I'll just read the front of it so that you know. We regret to inform you that due to a funding shortage, the FMA will be closing down later this month. The future of the archive is uncertain, but we have done everything we can to ensure that our files will not disappear from the web forever. The full audio collection will be backed up and available at archive.org. So my question is, how big is that? Let's open it up and look. That's why the inner data hoarder is touched, is a lot of data hoarders are going to probably try and grab as much as they can from this. It's very unfortunate. The Free Music Archive has been a really cool place, but of course it's very hard for them to monetize it by any means. So let's see. Free Music Archive. I want to know, can I download the whole thing? I want to see like how much data it actually takes. That's my interest.
Because you'll download it.
I mean, that depends how big it is.
It's like, oh, it's only 50 gigs? Never mind.
No, I mean the other way around.
While you're looking that up, we should also mention the hard drive roadmap. You saw that, right?
Oh yeah, Seagate's hard drive roadmap.
Yeah.
Yeah.
I think that you should mention that.
Oh, the fact that they want to have a 100 terabyte hard drive by 2025.
Mm-hmm.
That's a big deal.
Yeah.
Especially because they're using their Hammer tech. And what's really important about that is these drives won't be much more expensive than now.
Mm-hmm.
So you could potentially see like a $500 or $1,000 drive that's 100 terabytes. SSDs won't be able to compete with that for a very long time. And that's something I've talked about before. And when we had MAMR, microwave assisted magnetic recording from Western Digital that they've been trying to work on, that they say, okay, well, it's more likely to last longer, like in terms of the reliability of the disc and have less issues and stuff than heat assisted magnetic recording from Seagate. A, we haven't seen it used in anything yet, whereas Seagate has a lot of testing done with Hammer. But B, the density doesn't scale up to the needs of the market. If hard drives are to stay competitive, we need something like Hammer to be able to super scale hard drives.
Yeah.
And that's something that Hammer can't do. Maybe 30 terabytes. And it's like, for a good price, that's competitive for a while, but 100 terabytes for like $1,000 or less.
Yeah.
That's going to be competitive for a very long time. So I'm actually not seeing like a download all thing. Like, why can't places like this just provide a frickin' torrent link? That's the easiest way. If you want data to not be deleted on the internet, something that's a collection like this, you go to Data Hoarder, you post a torrent link. Mm-hmm. That's what was done with the 600 gigabytes of potentially like free, open, but oftentimes paywalled research articles. Mm-hmm. I downloaded that whole thing because there was a torrent link, and now I'm seeding it for all the other people that want to download.
Yeah. Speaking of torrents and just in general about research articles and stuff, Bill Gates and a few other, mostly Bill Gates, super rich people, are making a big push to support a few initiatives that would make all research articles free.
Good.
Yeah.
They should be. I love reading white papers.
Information should not be held behind a paywall.
No, it shouldn't be. You shouldn't have to. That's one of the beauties of the internet. You shouldn't have to pay for an answer to any question other than company secrets and government secrets and stuff like that. But educational information.
I want to buy all the government secrets for $12.
Yeah, there you go, exactly. So, and to end this all off, that brings me to a point, is even though we are a PC-focused channel primarily, we talk about all tech on the podcast, of course, I just want to still give kudos to phones. Mm-hmm. Phones in general. I'm a tech nerd, you're a tech nerd, I'm a PC nerd. I love PCs and stuff way more than phones, but I want to give kudos to a singular device that can be sub $500 that can give a person that's all they can afford access to everything in the world, from MMOs to games to social media to communication to safety to GPS and to the information on the internet available for educational purposes. Yeah. It's something I thought about a lot this week for whatever reason, and you made me think about it, so I figured I'd bring that up, as that's, a lot of people watching this are probably like, my phone's whatever, I set it down and have everything go to my computer at home. That's great for all us tech nerds, but I think it's amazing that a single device between $200 and $1,000. Yeah, especially with seeing such good, like, $200 phones recently. Which is a really important thing. And I think everybody being able to have that kind of access to the internet and stuff anywhere is a really remarkable thing for humanity. Yeah. And I would maybe go as far as, a lot of us say, the most amazing modern innovation is the internet. And I would say right next to that is the phone, because access to that is just as important. Yeah. So, very cool. Very cool. It's like almost emotional. Yeah. And you can play RuneScape anywhere now. That's true. So, and regarding that aspect, like, I think most games on phones are horrible, right? I've played a lot of MMOs on phones. They're never fun. I'd rather play games on PC. There's a lot of people watching this that would be in the same boat. Yeah. But at least, and of course you also have the big EA and stuff taking advantage of microtransactions because the game's, it's a $3 game, I might as well buy it. But it's really cool that normal people that couldn't maybe otherwise do that can get into that sort of thing. And it's because it's a single device. We know consoles can be cheap. Yeah. But it's a separate cost. And this is one thing that just handles everything. And $500 every 2 years, being able to access that much stuff is very cool. So camera, all
Yeah.
that stuff. It's just incredible. So to end off this extraordinarily epic podcast, because I have to make more epic puns at the end because, well, frankly, AMD is competing quite epically. That was really bad. Anyway, thank you everybody for watching. This is WordCast number 69. Wonderful episode here. A lot of good stuff. A very long episode. And obviously, we'll have the cutouts of stuff. Although if you're here, I'm assuming you aren't going to be watching that, and that's cool. We've got some reviews coming out next week and the week after. New video series that I'm starting up at some point, and a channel update to come soon to talk about that video series. So keep an eye open for that, and don't forget to check out all the links in the video description. We'll have links down there to all the source links, an article that has all the source links. Also, the links I said to delete your Facebook. And then we'll also have links to our Patreon page down there if you're interested in giving us a monthly contribution, our website, our social media, all that kind of fun stuff. And, of course, leave a comment. We try to reply to every single comment that we get. So, anyway, goodbye, everybody.
Bye.
Aren't you supposed to shut your laptop for the end of the stream?